Hey guys, today we're going to do three systems of inequalities. To solve a system of, our objective will be to solve a system of linear inequalities. And the essential understanding, you can solve a system of inequalities in more than one way. Graphing the solution is usually the most appropriate method. The solution is the set of all points that are solutions of each inequality in the system. So, an inequality and a system of inequalities can each have many solutions. A solution of a system of inequalities is a solution for each inequality in the system. Overall, what we're working with is two inequalities. We're going to be graphing both inequalities, and we want to see where both of these inequalities solutions overlap. Where they overlap will mean that they satisfy both inequalities. So 1, we're going to take our first equation, 2x minus y is greater than or equal to negative 3, and I'm going to solve for y by subtracting 2x. Negative y is greater than or equal to negative 2x minus 3. Divide by negative 1. Since I divided by a negative, it's y is less than or equal to negative 1. Dividing on both sides is just going to flip both of the signs, so 2x plus 3. Now graph that line. Go up 3. My slope is 2, so up 2 over 1. As well as down 2 to the left 1. And I'm going to connect with a solid line because it is less than or equal to. I now have to pick a test point, so I'm still going to pick 0, 0. And is 0 times 2 less than 0 minus 0 greater than or equal to negative 3? Is 0 greater than or equal to negative 3? Since this is true, we shade the side where that point is. So I'm going to shade here. I'm not going to shade too much so that I can still graph my other line. Since this second equation is already in slope-intercept form, I'm just going to graph it. Start at my y-intercept, 1. My slope is negative 1/2, so down 1 over 2. Or up 1 to the left 2. This I'm going to connect once again with a solid line. And now I need to figure out where I'm shading. So I pick 0, 0. Is 0 greater than or equal to negative 1/2 times 0 plus 1? Is 0 greater than or equal to 1? Since this is false, I need to shade on the opposite side of the green line. So I'm going to shade on top of the green line. Now, my solution to this system is where the green and the red overlap. So the green and the red overlap in this blue section. So that would be my solution set, and any point in that region would be considered a solution to this inequality. Solving a linear and absolute value system. So what is the solution of the system of inequalities? Y is less than or equal to 3 and y is greater than or equal to the absolute value of x minus 1. Y is less than or equal to 3 means that I have a horizontal line at 3. I need to pick a test point, so 0 is less than or equal to 3. Since this is true, I shade down here. Now I have y is greater than or equal to the absolute value of x minus 1. If I have absolute value, I have to remember I start with my vertex. My vertex is the opposite of the inside 1, 0, because there's no number on the outside. So I'm going over 1 and plotting my point. The slope, which is the number being multiplied on the outside of the absolute value, is 1. So my slope is up 1 over 1. So on my axis of symmetry, I go up 1 over 1, up 1 over 1. And I reflect those points over the axis of symmetry. I connect with a solid line. I'm going to erase my axis of symmetry so I don't get confused that that's not any boundary line. And now I need to figure out where to shade. So I'm going to test 0, 0. Is 0 greater than or equal to the absolute value of 0 minus 1? Is 0 greater than or equal to the absolute value of negative 1? The absolute value of negative 1 is 1. Is 0 greater than or equal to 1? This is false. So since this is false, I shade on the opposite side of the blue line, which is over here. So I need to see where they overlap, and these two overlap in this triangle section here. So that purple is where my solution would be. Please note that you need to make sure you have it very visible of where your solution is, and it is very helpful to use different colors, so please make sure you bring different colors to class next week. You guys try this one. See you tomorrow.